I will keep an eye. Okay, good afternoon for Canada and hello for those who are out. So it's more a user presentation. So we can consider the backscatter from a specialist point of view, physician, but you can consider the backscatter as a user of backscatter. And why are we using backscatter? Can we remove this? Yes, okay. Why are we using backscatter? Because here you see a map of the Belgian part of the North Sea, and we have a lot of sand extraction. You see the limit of the concession for sand in the map. And each year, more or less 3 million cubic meters are extracted from these areas for the industry, for breeding, for construction, and by mean 2 million of cubic meters are extracted as well, but for beach maintenance. There's a program to maintain the beach safe. And yes, thank you. Sand extraction has a lot of direct and indirect impact of the marine environment. And we use the backscatter as a proxy to characterize this impact, to follow, to track it. We have this model of impact quite complicated, but very robust. But we can simplify that. We can consider the near field impact, the direct impact of the extraction on the bottom, the seabed bottom. We use the bottom backscatter to quantify that. So very old story. We started this job more or less 25 years before. And now a new story is to evaluate the far field impact of the extraction. As you see, a dredging vessel is producing a lot of plume, sediment plume that overflow. And this fine sediment can be dispersed by the currents and, let's say, contaminate habitat protected areas. So we have to track that, to quantify that. It's a very complex question, and we have a lot of questions on that for the Backscatter working group in this too. Just to keep in mind that this job is a legal obligation in Belgium. We have to do that. It's a law. We start a long time ago, and just a period of that is my golden years. That was between more or less 10 years of more than 10 years with using the same eco sounder on the same vessel. Very simple method, very robust. We keep always adequate and constant survey parameters. We check the repeatability, and we have an extremely good time series. We use the same cooking recipe for the backscatter with the sonar scope. We removed all the Kongsberg adaptive correction. We correct for attenuation in sonified area, and we just keep this part of the angular response, what I call the backscatter paradise sector, minus 30 or 30 to 50 degrees, and we map and stat on that. And this is an example of a very nice time series, more or less 10 years of measurement on this area. And you see the trend, the backscatter trend is really obvious. You see that the backscatter level by mean is declining. And you can follow that on the map. And here the extraction just extracts the first layer of sand that is much rough and coarse, and put the second layer at the bottom. So very simple system and very robust way. Very huge time series of backscatter data on different places using that. But things are more complicated now because the old Belgica was sent to Ukraine just before the war. And now we have a new vessel with a new multi-beam system. And what we want to do is finally to combine the measurement from the little vessel from the Flemish community, the Simons with the new Belgica. We want to share the data, to merge data in a common time series. We want as well to make the junction with the old time series acquired with the EM3002, same frequency, always at 300 kHz. And for that, of course, calibration is required. The Belgica visited 2 times the Carré Renard in the Brest Bay in 2015 and 19. And we collect very good data on Carré Renard. And the graph shows you in blue is the angular response of the EM3002. Don't calibrate. The green line is the reference angular response from IFOMER, fully calibrate. And the green line is the angular response of the Belgica shifted by 5 decibel. So we observe more or less a 5.5 decibel lightning of difference between the reference and our measurement. Coming back to Belgium, this is the time series on the Quinter reference area. And on the Quinter reference area, we observe a mean level of, let's say, minus 18 dB. So by then, the calibrated Quinter reference level should be minus 12. Just apply the shift. And we use that to calibrate, we use that principle, that assumption to calibrate the new multi-beam on the new Belgica on the Quinter area, because we are waiting the venue of Frida and Laurent with their PK actives, and we are waiting that the Belgica is going on the Carré Renard to have a direct measurement. So, metrologically speaking, it's not really solid, but we are doing that because we have the choice at that time. So, you say 2 lines on your reference area. At different sector mode, plus X, blah, 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 all the mode you have, you say 2 lines by each for each settings. You correct for the attenuation and the insonified area based on the real angle, incident angle measurements. And after that, we use Sonarscope and the IFOMER model to modelize our data. We select only the single sector mode data because we have only the one frequency. We don't have this problem of multi-frequency per sector. We have only one frequency, so we modelize the data acquired at single sector mode, long and medium pulse lengths, and we create our own model. This is the red curve, and we oblige this model to pass by minus 12 dB at 40 degrees. So we push the model to be at minus 12 dB at 40 degrees. Okay, so it's like you create your own reference model by this way. And after that, what you have to do is for each other mode and each other settings, you calculate the base correction per sector and angle based on this model. So the shift between your data and this model, and the results are you have a full database of BS correction file that can be applied directly on board when Kongsberg will provide us the capability to use the real-time BS file. But that can be used now in post-processing, and we can post-process the old data. That's very important. That question was, I don't remember who was talking about that, to use the old data and to recalibrate old data. We can do that. Sonarscope allows you to do that. And as an example, you see this is the whole backscatter model directly. We merge the sector, but obviously you can see the central sector is much higher than the lower sector. And after applying the correction, what you get is a calibrated backscatter data, backscatter value, with the beam pattern correction. And this is the data that can be used to classify the seabed because it keeps the angular responses. You don't remove the angular link. But at the final, you remove the angular link and you get la belle image, the image that all the geologists of the world want to see on screen. Without any artifact, subtly you can see still a little bit the specular, but the image is very good. It's a backscatter that is flat. I mean here, because as you see, just a comment on that, because I see that I have some time. It's not so good as the carré renard, because you see some strange things in this area. Why? Because despite the fact that this area is probably the first area of the world that has been closed and defined in the marine spatial plan as an acoustic reference area, fishermen are still going there and disturb the seabed. You cannot control everything there. So sometimes when we pass there, we see a lot of fishing tracks and I say, wow, it's not authorized. Why they are there? But we cannot control that. We control the sand extraction, but not the fishermen. Sand, for a large part of people, sand is sand, but for us, sand is not sand. We have many sands. And yet, the backscatter, just as it is proceed now, just allow us to classify the sand in, let's say, two, at least three categories. The publication of this paper is very interesting paper. It's like a light. It's, they say, okay, we can separate contribution for the substrate for contribution from high scatter, just based on the statistical analysis of the data. And I think it's really promising for us because we like to improve the sand classification, just to extend, to better understand the relation between sand and acoustic. So there is a project in course with UNP, is Université de Brasilia. So you know where it's coming from, Brazil. So there is a project of that. Future spin-off, a new spin-off, sand classification. Here you see that with the Simon-Stevin, the little research vessel, we follow a dredging vessel, was occupied dredge, and we track the plumes. That this is a plume as it can be catched by the acoustic. It's absolutely fantastic here because the pilot doesn't use the thruster, so we were on complete silence, and we really well track the plumes. So we can see the overspill plume, the density flow, so we can really characterize the plume, and you see on the program how much is changing from time to time. But to really evaluate the far field effect, it requires a lot of measurements. First, it requires that you have to know the source and the overflow. So you have to take samples at point 1 and point 2. Some of our colleagues will go on the dredging vessel and collect samples for the overflow. You have to know, you have to real-time integrate the hydrodynamic plume dispersion model with the highest position of the research vessel. And on the research vessel, we have to use several acoustic devices and synchronize with in-situ segment measurements. Plus, we project to use drones to have a plume surface overview. All together. We project to do a campaign of 3 days specifically for that. But the main problem is that when you are on board, it's extremely difficult to catch water samples with the acoustic. Why? Because inside the plume, the amplitude in the water column is changing a lot in time and space very quickly. Only 2 seconds and 4 meters separate these two echograms. Or could you imagine that you can get water samples that is really representative of an amplitude at that point? It's extremely difficult. So that's the first problem, acoustic and in-situ measurement must be taken at the same time, at the same location. I'm not sure it is possible. Probably we have to think about a constant flux of water pumping seawater in one place and analyze constant flow of water. We have to think differently. Water detection limit, we don't know what are the detection limits of the multi-beam in terms of concentration and grain size. We don't know. It's unknown. So that's the reason why we are looking for measurement in a controlled environment that would provide answer to this question. And the delta frame, there is not a lot of place that can allow you to do such measurements. The delta frame, Xavier talked about that this morning, in the Netherlands can be a place like that. It's ideal to perform this measurement. And this project is already a spin-off of the Backscatter working group. Even we don't know if we can have the money to do the project. That's another point. So, as Xavier said this morning, present that I pass rapidly. We have done a feasibility study at a very good time between two COVID stop. We were exactly at the good time in October on the flume. Rida arrived from there with all his package of acoustics. And we use sand, we use marine sand. A dredger provided me kilos of sand. I filter the sand and we put the sand in the plexiglass gray tube that you can see on the image. So we just simply pour the sand gently on the tube, and what you see is absolutely marvelous. These are 3 ecograms showing you the sand, the same sand grain size, passing through the water column, different weight of sand, but with the same diameter, more or less the same diameter. And what is really impressive is that here you have 3 grams of sand passing through the water column. You catch it perfectly, so you can extract it and make some statistic on that. Yeah, and you see, of course, this is the echo integration, is the mean decibel value measured inside this volume of water within the time, plus the standard deviation. And this volume of water is more or less 1 cubic meter. So in the mean dB, and you see obviously the link between the level of dB and the weight of sand. So, and I will conclude, I'm a little bit late. I will conclude by this slide that we expect to get models to interpret water column data, and that can be as well a new spin-off. Thank you.
Mark? We're ahead of time, so great. Next up we have Tim. Any questions for Mark whilst we switch over?